Tonight I would like to make this presentation of how to start a test bench. In other words, accumulating test instruments, what kind, how to get them for both people starting out brand new. I've taught the general class course here for about 3 years now, and I found that a number of people starting out say, well, I want to get some equipment, but I don't know what to get. And I don't really know how to use it. And I'm afraid that if I spend $150 on a piece of equipment, that I may not like using it, may not like doing that. So, what's available? The other thing is, I'm a downsizer. I moved down here 6 years ago in a nice, big 4-bedroom house, 2-car garage, never saw a car in it. I could have my Tektronix, the Hewlett-Packard oscilloscope, on a cart, and move it around. There's plenty of room. I can't now. I don't have the room for it. I have a 2-car garage. My wife insists on putting her car in half of it, though. So, I'm bound by miniaturization needs. So I put this together to try to give some sort of idea of what I have found and others have found to be very usable in an environment where you have limited amount of space or you're starting out. Some downsizers, you end up in an apartment and you got a roll-top desk. That's your test bench in your garage, so you've loved this stuff for years, but now you can't pursue your hobby. And you say, well, fine, that was then, I'll give it up. But it's still possible to do. There are ways of doing it. So let me start out here. This presentation is going to be a mixture of slides and also of some live demonstrations. For people starting out, if you have no equipment, I would suggest, start out with a voltmeter. Measure voltage. This was kind of nice, measure voltage. This is not a very expensive one. This happened to be from Harbor Freight. They have coupons they send out, and sometimes this is on the free coupon. You get a coupon, you get a free test voltmeter. A lot of them, like my Fluke, it's got one setting for DC. This one's got, it's kind of a range. So you have to tell it that, all right, I'm going to measure, under 20 volts around there and switch to that. A little more work, big deal. AC voltage also. I try to measure nothing above 110 volts anyway, especially if I'm holding onto the black wire, It also measures resistance. It's got a pretty decent little ohm meter. Now, this is probably not, 1% or 0.5% accuracy, but in many cases, you don't need that accuracy. I think these are rated at 2% or something like that. It's got, also current testing, which I've done very little current testing. I usually rely upon how hot the material gets, and that gives me an idea. This one's kind of neat also. You can test transistors on it, NPN and PNP. I've never done that with this. I have a couple of these. I keep one in the car when I travel. Just, if it says, it's very, very inexpensive. Oops. Well, I think it's $6.99 or something like that if you buy it, from Harbor Freight. Okay, so you can measure resistance and you can measure voltage. But then all of a sudden, there's other components. There's capacitors and inductors. And capacitors are hard to measure. Either they're open, or they're shorted. And if they're shorted, they usually don't work. If they're open, they may work, they may not work. You don't know what value it is. It's hard to tell. Same thing with inductors. Here's a resistance decade box. for those people that, it's kind of neat. It's got these little plugs. I believe these are called Berg connectors. Is that right? Anyone know? Anyone old enough to remember when this stuff came out? Berg connectors, I think. And they short out the pins. So if you want, for instance, 1 megabyte, this would start out with a 3 megabyte shorted out here, and you just keep going down and adding, next 100K. This would be 203 megabyte with 200K added to it. Now look, these are all surface mount. You don't have to solder these in. They come free soldered. This would be a challenge, for an experienced surface mount solderer, just because there's so many of them. All right, and then the next one goes down, and you got another 1K you're adding to that. And resistors are easy. Resistors, you add in sequence. You just add them up. The capacitance and inductance, it's different. But for resistors, they add up in sequence. If you put them in parallel, well, then you got to do a little calculation on them. But sometimes you may just need to have some sort of resistance. Now these are, I think, 16 ohm. These chips, I think they're 16 ohm. So you can't run a whole bunch of power through them, or you won't need an ammeter. You figure out how hot this gets real quick. Actually makes a popping noise, so it burns it out. This is about a $20 device. So you have a whole bunch of resistances that you can use and work with for 20 bucks. It's got little I forget, they got a name for these plugs. Banana plugs, yeah. The banana jacks, and these are banana plugs that go into it. Now I make my own just because I like to have something that's more workable. This wire here, right, very flexible, and because it's silicone, I buy silicone wire. Now this is a 20 gauge wire, all right. I have my banana plug, that it just screws it. I always solder the end, the wire, get some solder on it, and then it sticks good. And the nice thing is, most alligator clips, it fits into very easily, just slides in there. So, I got banana plugs in one thing to another, and I've got an alligator clip, that I can use, on different pieces of equipment. So, you buy a reel of wire and you make tons of these. I end up not losing them. I end up misplacing them, and I find them later on in a box somewhere. How they got them. So this gives you a resistance capability. And of course, resistors, the old color coding form. The first band, is the most significant digit. You get 2 more bands. The second band is usually they only give you three digits. Third band is a multiplier. Then the end here gives tolerance. Most of the resistors I get, they're all like about 10% tolerance. And I buy a lot of these from China. Pack of them, 100 of them, for 99 cents or something like that. The problem is, the Chinese, they don't understand red. It kind of looks pink, between pink and yellow. So I test them, and if I got a whole batch, at least I test a couple of them. I do some QA on them. One of my colleagues, he doesn't trust, he tests every part he builds with, so he still makes mistakes, so I won't tell you who that is. But here's the color code for it, and down here you can see, the gold gives you the highest percentage there, 5% or whatever. you find most of the resistors coming through nowadays are 1/8 ohm. They're real small. And especially for this,
1/8 watt.
1/8 watt. Yeah, watt. Good. And because of the way that the circuits are designed nowadays, a lot of them use like a tombstone or whatever. The thing is mounted vertically. So one end of the resistor goes into a hole in the solder, the other end comes back up and goes into a hole next to it. And because 1/8 ohms for a lot of the low power 12 volt and below kind of circuitry that we use nowadays is satisfactory to handle that amount of power, and it takes up less real estate on the circuit board. So the designers, one of the conflicts they always have is how small, can they make that circuit board and still get all the stuff in there, or do they have to expand it or whatever. So, I test some resistors, a lot of people test all of them. Now, one of the problems I've always had is, how do you measure inductance? It's just a wire, and if you put an ohm meter on it, it shows you, basically a short, which it should. If it shows an open, that coil is not going to work. This little meter, and I think we have a couple of these within the club.
You could buy one with a case on it too.
Yeah, actually, I have, there's a, what's called a script or whatever for my 3D printer that you can make a case for, I like these because you can set it down on things and it shorts out and sparks, it's a little more fun, It's a little confusing, it's that the buttons on here, are for inductance, capacitance, and L test either, and it's fairly accurate. We had at our builders group, we had a question about a device had a capacitor in it and thought the capacitor was not functioning, was either way out of tolerance or whatever. And we tested it, and sure enough, the capacitor was good. I go to capacitance, and you should. Okay, this one says. There we go. 99 microfarads. And what is it? There's 100 microfarad capacity. So yeah, it's close enough. But at least you can tell. Now, I don't know if that's any indication of like leakage or other things in electrolytics. I just, if it's the right thing and it doesn't work, basically, I throw it out and put another one in. There are other people that understand how to test for electrolytics and other things that are a little more sophisticated than what I am. But for a $20 piece of test equipment, it's, for somebody starting out also, and for somebody, that's operating on a roll-top desk, can stick this in compartment, very easily, and you've got, I like those ones that have all the little cubby, pigeonholes in them or whatever. They're kind of neat. This is $28. I lied. $28.99. Whenever it was that I bought this on Amazon. I buy most of my stuff on Amazon, and the reason is because That way my credit card is in one place. So if something really happens to my credit card, you know, I don't have to search through a whole bunch of them. I do some things to PayPal and maybe twice to Alibaba. But, you know, I'm always afraid of, you know, overseas transfers to somebody I don't know. Now, you can get also a capacitance decade box. And these here, these are a little neater because all you have to do is flip the switch up here. And you know, I put the burr connector in. And you can go, these are 1 microfarad, you can add to it. Now, capacitors, as you know, add together in parallel, not in series. Resistors are in series, capacitors are in parallel. And so, you know, basically all you're doing is you're adding more plates, you know, as if you had, you know, a sheet of glass and aluminum and keep making it, you know, so it gets larger. So this one, you can add, you know, in groups of 10, and then you do microfarads, you know, neat little system. And again, it's using banana plugs. And this again is, I don't know, about a $28 one or something like that. So you can test resistance now and capacitance. You know, so you got two capabilities so far. And let's see what this one, where is it? Ah, this is cheaper, 20 bucks. And then this one, and those for electrolytics. This one is, you know, for the these goobers here, technical term, you know. And again, you can select them in, you know, by checking one from, you know, one that's, you know, first, I'm not sure what happens when you know, take the leads out of here to connect it into the circuit, and you got like 1 or 2 nanofarads, you know, just the capacitance around the wire is probably going to add to that in some ways, but you know, I don't deal with that high frequency stuff. And this electronic salon, this is the one that, now, here's one that has inductance on it, all right? So, my meter here will do inductance, and I think I got an inductance board. You all can look at these afterwards if you want to come up and hold them and stuff like that. Okay. We have the antenna that John is going to use, this 6-band antenna that he bought. I bought one like that originally a little bit before he did, and a good friend of ours is designed, you know, he's an engineer and he's got to take everything apart. So he's been taking my antenna apart. And part of the thing that we have to do is you know, look at the number of coils in there and inductance and you know, all the parameters for it. So it's very interesting, you know, looking at the inside of this antenna. Unfortunately, it's not on the air. It's in parts. Oh, there's my glasses. So, well, I'm going to have to do it the right way. It keeps slipping off. One in there. And one in here. Okay, so here are those burr connectors. You see how these are nice because they got a little bit longer tabs on them, so you can pull them up. You can hang on to them, otherwise they're smaller. So I'm going to pick, here's about 220 microfarads. Yeah, let's see if that works. Well, you got to jump both of them. I just missed, I put it on one. Okay, these are all just sitting on one pin, so they're not shorting out. They're just, I need a place just to keep all of these. All right, so let's see. What the meter tells us. I gotta change that to inductance. Come on, come on. I have to calibrate it first. The other thing is, you gotta keep the instructions for this little meter, because I forget how to use all the buttons on here. You press enough of them, if nothing else, reboot. Or reboot twice. This is a second meter that I had here. The first one, it's plugged a 12-volt power supply into it. It runs on 5. And so I bought another one. Fortunately, you know, they're it's not being nice to me.
Ken, you need a filter to catch the magic smoke and then you can put it back in.
That's right.
Well, you know, I looked at the little chip in there, and it was scarred. I mean, so I knew it was dead. Well, take my word for it. Anyway, it does measure inductance, and it measures it, I think, fairly accurately. The other thing is that this inductance board, you know, gives me a reference. You know, many times, you know, you want to compare something to it, you know, and so this, or just plug it into the circuit, you know, so to test, you know, it could be a phobia building or something like that, you know, so that gives you the opportunity to experiment, you know, with a whole bunch of different values. This is an interesting chart here that I found, because I was putting a kit together, and it says I need a 0.01 microfarad capacitor, and of course they're not marked in there. It says a 103. Well, what is a 103? You know, and some others is, you know, a 473. You know, they're all marked with the code. So the nice thing about this here little chart is I can go in here, and the 103, where is it? Right there. It tells me exactly what it is. It is in picofarads, nanofarads, and microfarads. It's a good little chart. You know, I used to know this stuff, but you know, when you're putting stuff together, all of a sudden there's a little bit of doubt. And rather than solder something in and say, you know, I'll take a guess, solder it, then you got to unsolder it if it's wrong. So there's a nice little way of testing. Circuit Speedia or something like that is where I stole this from. Okay. This board here, 1995. So reasonably priced. Okay. So now with this equipment, you can measure resistance, you can measure capacitance, and you can measure inductance. You can't, you know, electricity you can't see. At least I can't. You can feel it. But then you have more complex electricity rather than just 60 cycle AC and direct current. All right? And it's important in many situations either to analyze a circuit or determine if a circuit is working properly to be able to see what that signal looks like. Well, that's the job of an oscilloscope. And like I mentioned before, I used to have one of these big honking Tektronix, you know, and you know, you needed a small golf cart, you know, to move it around the garage. It was huge. And more things on it. I've never learned to use it completely. I mean, it had more capabilities on it than I ever needed or understood or would understand. So here's a little device, and this is around, I think this is about a $30 device. And I think this is also a kit, all right? And it's not very powerful. I think it's probably 500 kilohertz or something like that maximum. So it's a starter. It's a curiosity. Somebody might want to use it. People that do audio work, it would be useful for them. You know, it really doesn't get very much into the radio spectrum, you know, where it would be useful. But it's a cute little device, you know, runs off of 12 volts, has one input, will display a number of different different waveforms, and you can sensor, and you can, you know, a number of controls on it. And again, you know, it's the sort of thing, don't lose the book. You know, not a lot of information on it now. But at least it does give you some information, you know, it gives you, you know, your rate and voltage and a couple things like that. This is the one that I bought. This is a Handtech. This plugs into your computer. This is 20 megahertz. It'll go up to 20 megahertz. And so it's useful for a lot of amateur radio. It's a $60 device. Now, the really neat device is the Rio, what's yours? The Rio? Rigel. You know, I mean, that is really cool, but that's just a little bit above my price point, you know. And it takes up a little bit of room. Not much, but, you know, a little bit more than this here. This one is oops, pretty easy to use. Comes with a couple probes. Fairly small package, and you know, you can tuck it away somewhere on your desk and just, you know, have the probes coming out. And plugs into the USB port on your computer. The drive, you know, a lot of these things people say, oh, geez, I don't know, I got to change drivers or whatever. This one is pretty easy. You know, most of my computers recognize it fairly well, pretty fast rather. And where is there? Okay. There it is. Okay, so that looks nice. Now let's plug in something here. And the first thing you usually do is, you know, you do the compensation on your probe. How's that look? Pretty good? Yeah. Probe's not half bad. It hasn't changed. There's a few artifacts that you'll see on here that come up. But you know, I don't know that it's that bad. I mean, this tells me, you know, pretty much what I want to know. If the rise time, you know, if I'm looking at this edge here, I can go in and open this up. Where's my edge? Hey, I lost my knobs. is it over there? Oh, no, anyway, the knobs are off on the side here. And I really got to get it back. I don't know. I thought this was it here. Yeah. I'll do it without the knobs. The next thing that you need, after you want to look at that, you may want to generate your own signals. And we'll go to well, here's a frequency counter. You know, see, this was a kit also. This is $20. This is an expensive signal generator. This is a $60 one. But the nice thing about this is it will do sweep. You can partition your sweep, you know, if you want. So if you want to check, for instance, a bandpass filter, all right, for 40 meters, you know, you can start the sweep down at 6.5 megahertz and stop it up at 8 or something like that, and watch and see, you know, how it changes, you know, what the curve looks like. It'll do triangular wave. I don't know what triangular wave is used for. I've never used it.
Synthesizers.
Sawtooth wave, however, you know, because you got a voltage that starts at top and drops down in a very linear fashion. You can vary. I mean, this is what makes a scanner work. This voltage, a voltage like that, is applied to a variactor capacitor. You know, the voltage on the capacitor changes that capacitance, therefore it changes, you know, the resonant frequency of the circuit, and that's how all scanners work. You know, so you know you can generate one of those if you need with this here. But this little one that I have here is kind of neat, and this is in a fairly small package. Again, they all kind of look the same. And see if I can hook this up to this guy here. And we need to plug in some voltage. I'll take a chance. I think this is 5 volts. Hey, it lit up. No smoke.
They don't smoke anymore, they just don't.
Yeah. Well, the thing is, I hate to take a chance like that, then I gotta buy another one. My wife says, why are these bills so high? And for it seems the same thing. It's, well, I don't know, it must have got lost in the mail. Okay, so that's, I can change the frequency on lights, nice little sine wave. Let's see what that button does. And this sine wave generator, this goes up to, I think, 8 megahertz. Usable for some things. So you can get some sine wave out of it, and again, fairly cheap. Inexpensive, I should say. Okay. Where's my this signal generator I really do like. This is very handy. This is very nice. You know, it's fairly small. I mean, it's about yay big, like that. Okay, this generator here, a little bit better picture of it. It's got different function keys here so that you change the thing there for, like, one button, you push one, the sine wave, you push another, you get a square wave, you get a, you know, a triangle wave or whatever. This changes the frequency, the little button here, and this here will change the amplitude, you know, and here's the off switch that you should have on when you plug the thing in just before it explodes. So, Now, you got a whole bunch of stuff here to get you testing capability, but now you're at a point where you say, well, I want to build something. Well, there's a whole bunch of little kits available. Some are, I think one of the very first show and tell things I did here, I had this clock. It's a round clock with LEDs on it. And I built it, and I was so excited in putting it together. It's one of the first times that I did surface mount transistors. And, they got a tab on one side and 2 tabs on the other side. Well, I didn't pay much attention to them. You have to look at the side, and when they come off from the transistor, if they go down like this here, this is the feed. That means it's the bottom side. All right, well, I didn't want to be real careful. I turned it over, so the feed went like this here. And I still soldered it, and it don't work. It changed the transistor backwards, they look the same. The other thing too is this little solder iron here, it's got a nice sharp point on the front of it. Mine is about half as thick. They end up going round. They don't last very long for some reason. I never understood why that copper, evaporates, but it goes away. If you're going to start out soldering and you've never done anything before, you got a choice. You can buy a control solder iron and everything for about $120, or this is $6. And if you find out you don't like soldering, it's easier to throw this out than the $120 one. So, and for a starter, this is good. And you will find, like some of them, this is not a particularly, good handle, just plastic. After you use them for a while, it does, get a little red on your skin or whatever. This is, again, Harbor Freight. I think $6. So I advocate a lot of things for Harbor Freight. I have to tell you, I did work for them for about a year, maybe about 10 years ago. And so I know their inventory fairly well. And all of this stuff, it hasn't changed. And a lot of the stuff they got basically are things that are out of patent, or patent they got real cheap or copied or something like that. But I like their tools. Because a lot of the tools, they got brushes in them. And so, a drill, what happens in most of it is you wear the brushes out. And the modern day, the new stuff, you can't fix it, you throw it out. So in theirs, you're going to replace the brushes. So I kind of like that old-fashioned idea. So anyway, there's a very inexpensive option to start with. I'm going to go back to that. One of the other things that they have is they have this device, a third hand they call it, or something like that. You stick your solder iron in there, mine are usually laid right on the table, and, or it's on the floor. And what happens is that the cord catches on your leg and usually it falls in your lap, And they say, well, a lot of people don't know how I got those tattoos, but, so, right? If you're from Texas. So this is kind of nice because these little these alligator clips here will hold the circuit board, so that you can take solder in one hand, and the solder iron in the other hand, and make your joint. The magnifying glass comes in handy. I took mine off because it kept catching on things. What I did is I bought a pair of 3 power reading glasses from the dollar store. And it kind of magnifies things. I have to hold things, about, 8, 10 inches from my eye. If you wear them, for like a few hours, 3 or 4 hours in a row, and you get up, you got to be careful. You got to blink your eyes so they refocus on the floor. Otherwise, you can't see anything. Again, these are under $10. Whatever. Now, solder. Solder is very important. Do not use plumbing solder. Do not use acid core solder. This is rosin core solder, you know, and it's 60% tin and 40% lead. I like, you know, 1 millimeter diameter. It's easy to work with. If you're going to solder something real large, you know, you may have to use a lot of solder on it, you know, a lot of wire on it. But otherwise, it's, you know, pretty much in between. There's a group of people in a publication called Solder Smoke. You know, people that, you know, do a lot of it. And some people say, oh, you know, the fumes, you gotta ventilate it. Well, I don't know. That hasn't affected me. You know, for years I've been doing it very well. And the fumes, I think, are from the rosin. I'm not sure what's in rosin. Pardon? Yeah, well, I look at it this way. I've eaten enough bad stuff in my life, you know, that if that didn't kill me, this probably won't either. Solder's expensive. You know, I think it goes by the pound, and I think, I don't know, like maybe $20 a pound or something like that. This is a smaller 50-gram one, and it's probably in the, you know, under $10 range. I want to go back a couple things here. This is another alternative to parts. You know, if you need parts, you can buy them. You know, buy the 100 pack of 100 resistors, 100 there. This is a nice little kit that I found. I think this is in the $20 range. This gives you some LEDs to play with. All right. It gives you, you know, a bunch of resistances, and they're on production. These are what I call production tapes. All right. In industry, they'll take a reel of this here, which is probably about 1,000 feet long, and have all these parts, you know, glued on each side. And as they come through the equipment, there's a machine that separates them, grabs the individual parts, bends the leads, and sticks it in the board. I mean, that's how most production is done nowadays. So as a result, there's a tremendous number of these available, you know, for overproduction. You know, somebody makes them, you know, they need 1,000 reels of these from some company, but they'll probably make about 1,000 in, you know, in 20 or something like that, just so that they got enough. So they got 20 to sell, and it goes in, you know, to the aftermarket. I've got a roll of these of LEDs given to me, you know, by one of our colleagues here, and I've managed to use 8 of them so far, you know, but I'm working on it. For the class that I teach, you know, I actually give them out. You know, it's like show and tell. You're like, okay, you know, you got a 3-volt battery at home, coin battery, well, you can make it blink, you know, do something or other with it. It also has the ceramic capacitors in it. Here's some transistors, different values. Diodes, I always need diodes, you know, from one area. And some packed electrolytics. And it's, you know, it's a nice little box. Everything together, and I think these are even labeled. I got one that had all resistances, you know, for a gazillion of them, and each one is labeled. You know, it's got a little sticker on it, so I don't have to worry about looking at the color code. I still test them, you know, have a bad habit or whatever. So, okay. 50 grams, how much was this? Where's the thing here? $8 for 50 grams. So not bad. And the other thing is, you get too large a thing, you got to store it. You know, if you buy a full 1 pound reel, you know, it's hard to work with. You wind some off, but then you got this 1 pound reel of stuff sitting around. So I always take a empty spool or something like that and wind about 10 feet onto it, just so that I've got a little bit smaller desk space occupied. One other thing that comes in real handy, this was kind of an afterthought of mine. You know, everyone's got screwdrivers, Phillips screwdrivers and that. Lately, because I buy a lot of Chinese kits and parts, they're all metric. So all my English stuff, you know, I'm replacing with metric things, you know, and got to learn metric measurements. And, you know, like this is 30 millimeters. Well, how long is 30 millimeters? I don't know, you know, so I'm learning that. One of the best tools that I have, that I bought, and I think I've got 3 of them laying around, and, most of them need a charge, but these electronic screwdrivers, these are really handy. We used one just a couple of weeks ago for, you know, had a cabinet that had a whole bunch of screws in it, and, you know, you can take the screws out, you know, real fast. The problem is, when I was working, I had a guy that worked for me, and we would buy 100 computers, PCs that would come in, and he'd have to put in a Ethernet card into each one of them, open them up. And he had an electric screwdriver. Well, he'd put them in, but as, you know, he would crank down on it, he would wait until it would really torque. Well, the problem is you couldn't get the stupid screw out later on. It would, you know, almost seize in there. So when you use these here, you kind of feather touch it at the end, just so that, you know, you don't have to crimp it in. If you need something that's really, really tight, you know, you put most of the threading in with it, then take a regular screwdriver and bend it down. So anyway, again, you know, fairly inexpensive. You know, very useful. This is a new addition. This is after you're now very sophisticated. You have your test, your oscilloscope, you got Regal, you got all kind of test leads hanging around, and you're building antennas. And you need to do some work on the antenna. And so you need an antenna analyzer. Well, MFJ makes a bunch of them, they're good. I've got a couple that I bought from China. You know, they're in the $300 to $400 range for the nice stuff. The Comet one, I think, is like the premium analyzer, but it's expensive. This is a kit. It's from a German amateur group to put these together. This was about $200. It says $150, but that's in pounds, you know, and by the time he converts it, it's $200 when it gets here. This is a vector analyzer. And what it shows is this standing wave ratio over this range. The center around here is 7,800, all right, 7.8